Anand, for the introduction. Good afternoon, everyone, and I hope you guys are enjoying the conference. So first of all, just a quick show of hands. How many people have worked with Arduino or Raspberry Pi, Internet of Things before? Okay, some numbers. What language you used? Java? Yeah, speak up, speak up. JavaScript? Ruby? Okay, great. There's somebody from C, C++. Anything else? Python? Python? Okay. So you have worked with Ruby. Nice. So great. Okay. So because most of the people here are not aware of it, so this is kind of a perfect talk to get you introduced to Internet of Things and how you could make it possible with Ruby. So my name is Anmol Agarwal, and I'm a UX UI designer. I started coding about a year and a half back with Ruby and Rails, and I've been working on just side projects, but throughout time I have gained some experience. And I'm autodidact, means everything that I know is self-taught. During my free time I sketch and play basketball. So first of all, I'd like to show you a video which actually got me hooked to Internet of Things, and after watching that video only, I decided, okay, I need to learn this, means how is it even happening. So it's just a 2-minute video. Okay, pause. Yeah. It's coming.
And I'm Aaron, and we're graduate students at MIT Media Lab.
We have a dream that everyone is an inventor. So we created Makey Makey to let you invent just by alligator clipping.
Alligator clip stuff like bananas to your Makey Makey. When you touch the banana, your computer just thinks you're touching the keyboard.
The front has arrow keys, spacebar, and mouse left click. When you're ready for more, flip the Makey Makey over and you've got more keyboard keys and support for the mouse. You can even use the board like an Arduino when you are ready. No programming, no breadboarding. You don't even have to install software. Just plug it in with USB.
Order your Makey Makey today and start changing how the world works.
Yeah, never thought I would see a day when I could play bananas as piano. Anyway, so this is the video that my friend showed, and I was immediately hooked that, okay, I need to learn this stuff. How is this even happening? So this concept is called Internet of Things, aka IoT. And you might ask, what is IoT? And there are like numerous explanations to that. Everyone would explain differently. But I would give you just a simplest definition, which is IoT is basically connecting any device with an on and off switch to the internet and or to each other. So what does it mean? So usually we have smartphones and laptops which communicate with the server and store our data into databases and all. But with Internet of Things, it's not just with the smartphones and tablets and desktops. Means you could use everyday the things that you see around yourself every day, like your lamp, camera, bicycle, washing machine, coffee maker, anything. And basically, you can make those things talk to you. They can understand you. So suppose you are coming back to home from work. Your home understands that, okay, you have just arrived. So let's turn on the fan and lights for you and maybe play a relaxing music at the background. So things are means non-living things or daily life things are talking to you. So that is Internet of Things. And I hope that by the end of this talk means you would be excited about what IoT is and make many projects and libraries in Ruby. So what about Ruby? Means how's Ruby in the landscape of IoT? So when I started learning about it, and I found out that IoT is currently dominated by 3 languages: C, C++, Python, and JavaScript. And I found out that there were not many projects in Ruby, and it was quite surprising. And because Ruby supports modular programming, means we reuse the code, we use gems all the time. And although I know JavaScript, but I love Ruby too much to even do this Internet of Things in JavaScript. So I wanted to do it in Ruby only. Then I began to look, means have somebody even contributed to this. So I YouTubed Ruby and Arduino, and these 3 people came up: Austin Vance, Ron Evans, and Jim Varick. And I'll tell you what those guys have done. And so the Ruby gems to work with Arduino currently are 3 of them: Serial Port, R2, and Dino. So if you guys, most of the people haven't worked here with Internet of Things, so you have a microcontroller like Arduino board, and basically you define what components are connected to which pins and set it value as digital high or digital low, those kind of things. So the same thing of digital high, digital low, read, write. So those exact same thing that you do in C, C++, it's in Ruby style. So that's what Serial Port Gem is about. Next is R2. R2 is a very extensive Ruby library, and I highly recommend you guys to check it out. R2 is Ruby on robots, and as you can see that we believe that it's time to bring Ruby and robots together. And it's very extensive because if you check out this website, it supports the platform not of just Arduino, but also Raspberry Pi, BeagleBone, Sphero, joystick, even drones. So it's very, means you could really build a lot of stuffs in this. And next, the last is the Dino gem, which I started learning from. And this gem is made by Austin Vance, and this R2 is actually has been talked by Ron Evans and Jim Varick. So Dino gem is, if you see here, Dino is a Ruby gem that helps you bootstrap prototyping with Arduino. So it's a very simple gem, and I'll be using this to show my demos in the coming slides, because I think it's comparatively simpler to read, write, and understand. So that's what we are going to use today. So the demos that I'm going to show is just based on LEDs, and I love LEDs because of a couple of reasons. Because it's just a simple light bulb with 2 legs, one for the signal and one for the ground, and they come in various colors, and I stood a sketch artist, so I really love colors. And lastly, means you could create a lot of effects with just that simple component. You could turn it on, you could turn it off, you could make it blink faster or slower, or maybe blink in a pattern like a Morse code. So just by a single component, you could do so many things. I would like to take a time to tell you about little bit about Littlebits, pun intended. So Littlebits is a company which makes electronics, and if you see here, means they look like Legos. Means these guys have designed these electronics. I'll try to show here. So I don't know if it's clearly visible or not, but that's the best right now possible. So here's a battery, and here's the LED component, and yeah. So the cool thing about this little bits is that these components literally snap to each other. Means these components have magnets at their end, so and they have the polarity. So I can't stick with them in the wrong order. Means they stick in a particular order only. So this makes rapid prototyping even faster. So what you do is that you just snap it together and write the code if you want. It works even without code. So it just lights up. And they have the modules for almost everything, means input, output, sensors, Arduino board. And I think you guys should really check out, and I want to thank Little Bits for donating me the kit to make this talk even possible. And we'll see how this makes rapid prototyping even more fun in the upcoming demos. So enough talk, let's demo. So first of all, whenever we start learning any program, we usually start with the hello world. So what is the hello world of a hardware programming means? There has to be something. So it's called LED blink. And LED blink is, as the name states, we are just blinking the LED. So if we look into the code of it, so first of all, we have defined whatever the gems that are required. Here we are using the Dino gem. I'm not going into the details of how to install the gem. So, but it's a very simple 3-step process. You could go through the documentation. So you install the gem, then there is a terminal command which generates a sketch, and you upload it to the Arduino. So the purpose of that file is that your Arduino understands the Ruby file that you will be executing. So I'm connecting the Arduino right now. So if we just briefly go to the code, means it's very simple. Here, first of all, I'm defining a board. This is from the gem itself. Then I'm defining an LED. So LED is a new component which is on pin 1 on the board which we just defined. Then here's a block where we are cycling between on and off values. And at one time, whatever the value is, it's sent to the LED for half second. So if we try to run this, okay, I think that I won't be able to photo booth because cable is a little small, but still, otherwise I could show the video directly. So here's the code, and this is how the little bits work. Means I'm connecting it live. Means at a real-time speed, you can see. So it is sticking to each other because of the magnets at the end. And here I'm running that same Ruby file. And it's ready, and the LED is blinking. So we got the hello world working in Ruby on Arduino. So you can see how small that code was, means under the like 10 lines really. So next demo we'll take a look at is, well, everything is not blinking in this world, so we control things. So why not control the LED with a button? So if we look into the code of that, it's almost same as the LED blink, but we add a button. So we have a button added here, and initially we are turning the LED off. So these on and off and whatever the methods that you will see with each and every component, it's built in the gem itself. So it's very simple to understand. So here we are calling a down method on the button. So down, it doesn't mean pressing the button down, but the voltage is down. So that is one gotcha that has to be taken care of. That's what the Austrian thought of when he was building it. So when the voltage is down, it puts button not pressed on the terminal and LED is off. If its button is pressed, voltage is up and LED is turned on. So if we look at the video of that, so it's the same, almost it's the same code. I'm connecting it live. So the pink color that you see is that the button, green color is the LED. So all the components are color coded too. So if we look at here, means pink color is usually the inputs, orange is something connecting its wire or Arduino, and green color is the outputs. So I'm pressing the button and LED is turning on and off. If we check into the terminal, we can see, yeah, it's running through code, although this could run without code, but in this instance, we are running it through code. So let's take it to another level. How about controlling the LED through Rails in a local server? So you can kind of see what's coming. It means we have started to build up on our last program. So if we look into the code of that, so here's the Rails app that I generated. It's got no models because I'm not storing any values in the databases or anything. So it's just got the controller and views. So the most important file in this program would be the LED controller that I generated. And LED controller has got 3 actions only, index, on and off. So when it's on, the LED is turned on, when it's, and we redirect to the root path. So, same with the off. So LED is turned off, and it's because root path is the index page, the index action that we'll be executing. And just at the last, we will see there's a private method called setup LED. So turning on and off, before that, we have to define the LED, and we do that before action here in the line second. So if we try to show you the video of that. So here I'm running the Rails app. I'm starting the server. It's ready. And here's the video is a little blurry, sorry, but you can see. So we got on and off buttons. Those are the 2 main components. And right now I'm just clicking it to see what happens on the screen. And you see LED is turned on and off through Rails on local server. And if I try to show it both at the same time, it's on and off. So now this is that was pretty amazing because it was running on Rails on local server. So that's very close to what we would build in a real life. Let's take it to another level. Let's control LED through physical button with PubNub. Means PubNub is a real-time service which you can use to. It's based on a WebSockets protocol, publish and subscribe model. So you could send and receive messages in real time anywhere and anywhere in the world. And PubNub claims that it could send messages anywhere in the world within 0.25 seconds, and it is. So we'll see through that. Although we can, I could have done with the Rails, but it would have looked just the same as the last one. But this is a physical button. So this is a very kind of a Big Bang Theory stuff. If we run the video of that. Yeah, so just the code before that. this code is a little long because of the pubnub. Just as the last program that we run, we are defining the board, button, and LED. Here we are initializing the pubnub. So we are creating the pubnub's new instance with a subscribe key and publish key. So publish key is responsible for publishing the messages to the channel, and subscribe key is responsible for getting the messages from the channel. And here's the subscribe block of the instance. It is connected to the channel called button pubnub. And whatever the data we get, and I'll just come back to this block of code. And same as the last program, when the button is down, we publish the message that is button status not pressed as a payload to the pubnub instance. And same with the up, it publishes the message button status as pressed when it's to the pubnub instance. And when we subscribe it, we are running the logic on the data means message that we received. So it's already in JSON, so we are looking for the button status key in the object that is returned. If it's not pressed, turn the LED off. If it's pressed, turn the LED on. Dead simple. So let's try to run the video of that. So here I'm just glancing through the code, what it is. It's the same. And again, making the connection. So this is an example where you can imagine that you have a button here in Bangalore, and suppose this LED is connected to the Arduino somewhere halfway around the world and subscribe to the same channel. You could turn it on from here, and that would turn on in real time within 0.25 seconds. So here I'm showing, just confirming, showing the channel, making sure that both are on the same channel, the same page. And from here I'm running the program. So it takes a while because it's kind of creating the handshake between the program and the pubnub. And once it's connected, it will show the message. Yeah, so we got connected, and now I'm turning on the LED. Although the response looks very real time, like you are using it locally, but believe me, it's going through all through the servers wherever it is nearby, in Singapore or in US. It's going there, coming back, analyzing the logic, turning on the LED. So that's happening in real time really fast. So this is terminal. Just to make sure that it's actually going there and coming back, this is the pubnub developer console, and you could see the messages getting published there. So here I pressed, then not pressed, it's pressed, not pressed. So you could see the response time here. So we got the LED blink, then we controlled it through the button, then we built it on the Rails server, and then we took it to the real time. But the world is not just full of LEDs. We have to interact with the environment somehow, and that's where sensors come into play. So for the sensors, if we look into the code of that, again, it's very simple. We are defining the board, then we are defining the sensor. And sensor have just one method on it, when data received. Because purpose of all the sensors is to receive the data of whatever they are built for, whether it's humidity or temperature or motion or anything. So we are calling this method, and whatever the data we get, we want to put back on the terminal. So if we look into it, so here I'm using the pressure sensor, which measures the pressure over it. Again, starting the program. and we start getting the values. So right now it's all 0, it senses nothing. Right now I'm showing you how I'm changing the values just by putting some pressure on the sensor. And we could change the value on the terminal like this. So you could see how sensitive it is. Now I'm trying to do it fast. It is collecting a lot of data in 1 second. So that is cool. Now, how could we connect the input to the output? So for that, let's try to control the LED through sensors. Again, just this is a very simple means. Now we got to combine the LED control of the button, but instead of button, we just put the sensors. So I think I'll just directly go into the demo of it. Right now LED is turned off, and now it's controlled through a sensor, not just the button. So one of the things that I really wanted to do was to control the LED through voice. But unfortunately, Siri is not open source, and integrating Google now with Ruby was almost impossible. So, but I found out a open source library called wit.ai, which is on natural language processing, which makes the task really easy, and it supports the Ruby platform. So, yay. So how does it happen running through the code? So again, the same thing, but here I'm using the wit.ai's API, its access token. And here I'm initializing it. After that, I'm starting the loop, where I'm using this method called voice query auto. So what it does is that it starts a mic, it gets your recording, and it sends the whatever is recorded to the application that's in the API, and you get a response. And the response, and on the basis of the response, I'm running the logic. So just a quick show of what NLP is. Means it's kind of comprised of intents and expressions. So like if you want to turn on the LED, so the intent is supposed turn on, but means lights on. But there are different ways of saying that same thing. You could say lights on, turn on the lights, or do not turn off the lights. So these are different ways of saying things. So that's what we match upon. And if I run the video of that. Voice, please.
Lights off. Turn on the lights. Turn off the lights.
And just to make sure means I'm not doing some magic behind the scenes, here's in the command terminal, it's getting updated in real time. So yeah, that was fun. Means I was surprised. Means I felt like a magician, really. So next thing is we have covered the fundamentals. So right now we'll take it to the practical applications. So one of the things that I worked on was a package delivery detector. So whenever you get a mail or parcel in your mailbox, you will get a SMS or email telling that you got a package and don't forget to pick it up. So I'm not going through the code here, but I'll show you the demo, and don't worry about it. All the codes are available, which I'll tell you in the last. So here's the pressure sensor I'm using for this. It will measure if the package has, I got a package or not. And here I just created a demo email, gcrcbangalore@gmail.com. Okay, so right now it's empty, there's nothing in the inbox. I'm running it, and I just put a parcel upon it for it to detect something. And if I check the email, I got the message. And if I go into it, I can read, you got a package, don't forget to pick it up. So that's one practical application. Another one is street lighting that you see on the streets, that when it gets dark, the street lights turn on. So simple. It's also dead simple, but here I'm using the light sensor, which senses the value of light around it. And based on that, it turns the LED on and off. So right now I'm using this angle because I want to show the setup itself and the terminal itself, so you could see the change in value. So right now lights are on, and the values that you can see in the terminal right now is like 790 or something in 3 digits. But if I turn off the lights turn on itself automatically, and you can see the value, it's 1022, 4 digits. So you could really see the change in the value. So that's cool stuff. Just a quick show of this is the last demo that I'm going to show. It's the project that I worked on. It's an earthquake warning system. And as we know, means how earthquake happens, there's a very less time for us to react to it and save ourselves. But I wanted to try for India. And these were the couple of hurdles that I found out. Means I found an Indian Meteorological Survey website which shows the latest earthquake report, but there was no APIs for that, and that's why I had to crawl it like every 10-20 seconds, because earthquake is such a crucial event where every second matters. And the doubt was that the latest earthquake report on the website, was it updated in real time or after 2 hours of when the earthquake came? Otherwise, it wouldn't make sense. Because imagine what 20 seconds can do to your life, your business, or your school. So I had developed a model for that. And this is a complete solution, means from sensing to sending in real time to the dashboard. So it's not just sensing and all, means it's monitoring and controlling and even warning. So the code is pretty long. Don't worry about it. Everything will be available. So here's the dashboard. I'm using freeboard.io. And here you can see the pane. Right now it's receiving nothing. This is the PubNub channel through which I'm publishing the messages. Right now I'll just run the code. And I'm replicating the earthquake effect because I can't wait for it. So I'm using the pressure sensor to generate that kind of effect. So if we see into the terminal, okay, it's 9.9, means that's scary. So right now I'm getting the earthquake alert, means, so I've set the logic that if the earthquake Richters is more than suppose 6, send print earthquake alert. So you can see it's firing on. And it's still sensing. And here you can see in the PubNub developer console, means messages getting sent there. And after this, I will show the freeboard. So you can see it got updated in real time. You can see the slope, this hump. So this is around 9 was, I will just hover over, although it's not too clear, but 9.6, 9.7. And as you will see this graph moving, it's happening in real time. So you are getting the data in real time. It's what the present systems use. And I just wanted to put an idea, means how much is possible with Ruby and Arduino. And at last, I would like to just show you, tell you a couple of resources. So for the books, you can read Getting Started with Arduino and Ruby, and that is probably the only book right now in the market related to that topic. You can read Make magazines to get the ideas, what others are doing, what are the get updated about the IoT industry, and get some inspiration. For the APIs and web services, you can use Timbu, WebShell, Maship, and IFTTT, which is if this then that. Although if this then that doesn't support a language, but it's very special for rapid prototyping, so I highly recommend you to check it out. For the dashboards, I used a Freeboard. You can use InfluxDB. It supports Ruby. And just yesterday only, I found out about Keen.io. And looking at their examples, it looks really good. And even I want to try it out, means how it goes. For the PubNub, for the real-time services, I used PubNub. You could use Pusher or Socket.io. And for the databases, NoSQL is usually the best for Internet of Things. So if you are developing locally, you could go for MongoDB or a graph database like Neo4j. And if you're concerned with pushing the data to the cloud database, you can use Firebase or Parse. And there's this article on PubNub where you could use a Ruby gem called MongoPipe, which does the same thing. And at last, I'm announcing Ruby Bits, which is my own series, the blog post series that I have just started working from this new year. Ruby Bits is Ruby plus Little Bits. As you can see, Ruby is a modular approach to programming, and Little Bits a modular approach to hardware. So I felt that they were made for each other. So you could find it out at tinkererforlife.com. And all the source code of the demos that I showed you are available on GitHub, and the slides also. And I can't wait to see what you guys could come up with. And if you build something, feel free to share with me, and I'll spread the word. So thank you.
I think we have.